Hello, good morning. Hope you are doing well. I'm doing fine. Please subscribe to our channel. It will allow us to learn together many things. Okay. Here we are going to learn how to do linear regression in Python. And what we'll be doing is what you can just see from my screen. We'll run and get the results about our linear regression. Okay, to tell you that, as you know, not only programming, analyzing data or doing statistical tests, whatever, Python also can do that. Then what is interesting with Python is it's giving more detail when the results are coming. Can you see how our results are? We have additional information, like AIC, BIC. Now, other information, for example, other software can give it, but we can also have after the result, just after the result, we have down there the additional information about normal distribution and so on. That's the point with Python. Then now is what we will be doing. Let us start step by step, but I have to clean whatever I have here, and we can now redo all those things and so on. And as we are just saying, Python is working with packages or modules. Then whatever we need to do around here, we need to import them. Yeah, they have already been installed, but we need to import them before to use. Then we will start from there, like this one, pandas, import pandas. As PD. It will help us now to import our data from the computer to here on our Python before to analyze. And now we need also another one, which is called stats model, import stats model. API. Okay, this one also will allow us now to run our OLS. Okay, for running matter, we can just go here and click on this arrow, green arrow, or maybe using Shift F10. Yeah, everything will work. Okay, that's the point. When you are running whatever you are running in Python, if you have process finish with exit code 0, meaning that everything was just okay, you can proceed. Now, since we have those modules around here, let us now try to import our data, the data we want to use, and call it data. We will say data, and now read. Okay, from here now, it depends now. We need to use pandas PD and read. And from here, you can see, depending on the format your data is, can you see? We have read CSV, we have read Excel. When your data is on Excel format, you will write this one. If it's on CSV format, you will take this one. On HTML format, you will take this one, and so on. Then here, this data I want to take from my computer is a CSV format. I'll just write it right the way it is, and then now I can go and take my data. It's this data I want to use for our training here. Then you need to click on it and right click, properties, and after properties, you can just come now and copy the location. And also bear in mind the name of the data, which one. Then we need to go back and paste what we copied. Then from there, I can copy, and now /back, and now the name of the data is which one, and add CSV. Okay, now I can run. Okay, I can just go there and click on it, it will run. Up to now, I have process finish exit code 0, meaning that is okay. Then let us view what we are just importing as data. Then we will try to print our data, not all of them. Let's try to see the 5 first rows of our data. and we'll use head, and we can now run Shift F10 or going just there and run again. Then we will see our data. Yeah, it's coming now. As I was just saying, it's 5 rows, but for the columns there are many, but Python contracted them. Can you see what is happening around here? Then it can give us, we can see how our data look like for further decision. If, for example, we want to see, rather than to see 5 first line, we want to see 5 last lines, the tail, for example, then we are using tail there. And now from there, we can just run again, Shift F10, for example. You will see what will come now will be our 5 last lines. That is, and what we have previously was there 5 first lines and 5 last line. That's the point now. And suppose that you want to know more about the data you are using, like the description of the data. You can also print it. Print now, data, and now saying describe. Then from there, you can have the description of data. It can just calculate those means, a minimum and so on of our data and show us. Can you see what is happening here coming now? Yeah. For each variables, I was having count here is the number of observation, mean, now standard deviation, minimum, and so on. That's the point when you want to check the descriptions part of your data. Now let us proceed. Since the purpose here is just to run linear regression, we need to define our variables, for example. Then let's say variables definition. When I'm talking about a variable definition, I want to talk about dependent variable and independent variables. Say that y is our dependent variable. Since what we want to do here is a linear regression, meaning that our dependent variable should be what? Quantitative continuous or quantitative discrete. Then we will say data. Okay, I'm taking now wage here. For example, let's us go and see how our data look like. Then from here, you can see what wage is a continuous or quantitative continuous. It's better to take it as dependent variable. That is wage. And now we need also to define what is our independent variable. Our independent variables here can be many. Then we are just taking first of all education, and after education we can take also experience. Then after experience we can take also married as independent variable here. Okay, we have it now. Then we can run again. Up to now everything is okay. Then as you can see, when we are defining our independent variables, there is no constant there. We need to add it to our model. And X, we will say that as same as the second one. Imported will allow us now to add a constant, for example, same as add the constant, okay, of to what X. Then we can do that now. Everything is okay. Since we have our variables, the dependent variable and the independent variables, so we can proceed now to linear regression or LS or multiple linear regression. Okay. Multiple linear regression here because we have many independent variables. We have more than one independent variable. When we have only one independent variable, so at that moment we are talking about simple linear regression. Then here now we can proceed saying model is SMS dot and now OLS. less, and we have our dependent variable, and next our independent variables and our fit. Okay, we can run again. Okay, that's okay. Now let's summarize our result. The result model, we'll call it result model, and say the name of model here can be summary, for example. Then we can now again run. Okay, the point around here is when we are running at the end, before to see whatever you are just doing, you need to print it. For example, now we are just printing data before to see it. The same thing with the model or the regression we are doing. We need after now, when I finish to summarize the result of our model, we need to print it before to see the result. Okay. I want also to precise whatever you are seeing here as red message is not meaning that we have problem. No, so it can be an information which is given. Here, for example, they are telling us that cryptosist, well, it's a test talking about the symmetrical distribution, is valid, only valid when the number of observation is greater than or equal to 20. That is just an information. Since we have this message process finish with exit code 0, meaning that everything was just okay, then we need to print the result model. Then I can just copy it now, put it there. Then we will see our result, for example, shift F10. Okay, you get it. Can you see the result? We have it now. Now, as I was just saying previously, we have more information around here compared to other software when we are using them to run our models or to do multilinear regression. Okay, what's the meaning of those kind of things? Okay, can you see the name of the model, or less the method is least square, for example, the date, the time, and so on. Now, coming here around, you can see that the R square is 0.649. What's the meaning of this one? Okay, first of all, when this value is greater than 50%, okay, or it is closer to 1, that means that our model fits the data we are just using. And now we can now give the explanation of it. It's like when we want to write really what the meaning of 0.649, we will say that the independent the variability of the dependent variable is explained by 60 is by the independent variables at 64.9%, or by 64.9%. The independent variables are explaining the variability of the dependent variable. That one is okay because it's just bigger, greater than 50%. Okay, the adjusted R square, I always will see that the adjusted R square is closer to R squared, and this one can help us when we are comparing two models. Now, but here, for example, what is most important, R squared, talking about the fitting of the model, since we are with OLS. F statistic is that this one coming to tell us about all of our independent variables taken together. Okay, we have what we are calling intercept model, which is this model having only the constants. Yeah, now here, the point is we are just the alternative, the H note or the null hypothesis saying that the intercept model is better than our model. Okay, then depending on what the value is, the p-value around here, it will allow us to accept or reject this H note. And as you can see, the probability of the p-value coming with F test here is less than 5%, meaning that we need to reject our H note and conclude that our independent variables taken together in the model, this model is better than intercept only model. That is the point. We have AIC, BIC here, which are good when we are comparing two models, like when we have nested model and we have complete model. AI-CBSE can allow us now to compare them, or even when we are comparing two linear regression model. But here now we have just only one. It will not serve us here, really. Now, about the result, as we can see, we have those information about the distributions coming down there. Those kind of information are not given by other software when we are running a multiple linear regressions. For this reason, it's better also to learn how to regress linear regression or other models with Python, because it's giving more details and information. Skewness is talking about the symmetrical distribution. When skewness is between minus 0.5 and 0.5, the data is normal, the symmetrically distributed. When it is not, this range is not, data is not symmetrically distributed. Kurtosis is talking about, can allow us to talk about the tail of our data. Are we having for our data the great tail, the higher tail, or we have only those one which are not great? Okay, higher tail meaning that's like maybe in the data we have those outliers and so on. And this value should, when it is greater than 3 or minus 3, less than minus 3, meaning that we have high tailed data. Yakibera here is now normal distribution test, which is can use the coefficient and the probability. Then for those tests of normally distribution test, the actual notes or null hypothesis is saying that data is normally distributed. Depending now on the value of p-value, we'll decide to reject or accept our H0. And as you can see, the probability of the p-value here is greater than 5%, mean that we fail to reject H0 and accept this H0. We see that the data we are using around here is normal distributed. Then when we are using really Python to regress your model, not only you are getting the result, there are some kind of tests which are given for free. That's the interesting things when we are using Python to run our linear regression. Okay, then for those who have not yet subscribed, you have a lot of to learn with Python. Hope that this one will help you. Just subscribe to our channel to allow you to learn more with us. Have a good day.